Hello, welcome to my channel. Today I will be starting with MAT102 Vector Calculus, Differential Equations and Transform. This is a subject based on APJ Abdul Kalam Technological University for B.Tech students. The prescribed textbooks are H. Anton, I. Byron, S. Davis, and the textbook is Calculus, Wiley's 10th edition 2015, and the second textbook by Erwin Kreyszig, it is Advanced Engineering Mathematics 10th edition 2015. Now we are moving on to the first module. It deals with calculus of vector valued functions. Now the first section, section 12.1, it deals with a parametric curve in 3 space. So let us check what is a parametric curve. A pair of equations, x is equal to x of t, y is equal to y of t, called parametric equations, which represents a curve in 2 space. So this equation together is called a parametric equation in 2 space. Let us consider one example. You take x square by a square plus y square by b square equal to 1. This equation represents an ellipse. The same equation also can be represented by the equations x is equal to a cos theta, y is equal to b sin theta. And these two equations together is called the parametric form of the ellipse. Now, second example, you consider the equation of a parabola. Y square is equal to 4ax. See, in this equation, y square is equal to 4ax, you can see two variables. One is x and the other is y. So actually this equation is in the Cartesian form. And the same equation can be represented in parametric form also. And this is x is equal to at square, y is equal to 2at for any parameter t. So these two equations together, when we are drawing the graph of these two equations, you will get a parabola which is same as y square is equal to 4ax. Now let us take the third example. For a hyperbola, we know the equation x square by a square minus y square by b square equal to 1. This is the Cartesian form of hyperbola, and whose parametric equations are x is equal to a sec theta, y is equal to b tan theta. So these two equations together is called the parametric equation of a hyperbola. Now we are moving on to the graph of parametric equation. A curve together with the orientation is called graph of parametric equation. So we need the equation with the corresponding orientation. Now what is orientation? A curve in 2 space is drawn in a specific direction as parameter t increases. This direction is called the orientation. Now here is a note. In 3 space, in 3 space there are 3 components. X is equal to x of t, y is equal to y of t, z is equal to z of t. Generates a curve in 3 space, and the curve together with orientation is called graph of parametric curve. Usually t belongs to minus infinity to infinity. T takes values from minus infinity to infinity. Now moving on to examples. The first example, the parametric equation x is equal to 1, y is equal to 1, z is equal to 1 plus t, where minus infinity less than t less than infinity represents a line through the point 1, 1, 1 and parallel to the vector v is equal to 0i plus 0j plus k. See how we are getting this result. In the equation x is equal to 1, y is equal to 1, z is equal to 1 plus t, you collect the constants. Okay, the first term x is equal to 1, y is equal to 1 and z is equal to 1 plus t, and that 1 is the constant. You form a triplet. Triplet means having three components, something having three components. So 1, 1, 1. So surely we can say that this curve passes through the point 1, 1, 1. And how we'll get the corresponding parallel vector? So in order to get the parallel vector, you consider coefficients of t. From the first equation x, it doesn't contain t. Okay, so we can put 0t, 1 plus 0t, the first equation, so that coefficient of t will be 0. That you can write as the first component. And from the second equation, y is equal to 1, it is given, but we can write y is equal to 1 plus 0t, so that coefficient of t is 0. So that you can arrange as the second component 0j. Plus the third equation is z is equal to 1 plus t, in which the coefficient of t is 1, so that the third component is 1k. Therefore, the parallel vector will be v is equal to 0i plus 0j plus k. Now look at the orientation. Here, the third equation says z is equal to 1 plus t. From this, it is clear that as z increases, here z increases when t increases. So as t increases, the third component z is also increasing. Therefore, the orientation of this line is to the positive direction of z axis. The equation of the line is, the orientation of the line is to the positive direction of z axis. This is the graph of the given equation with the orientation. Now when we are considering the second example, the parametric equations x is equal to 1 minus t, y is equal to 3t, z is equal to 2t, which is a line. Why this is a line? This is of degree 1. Okay, each equation is of degree 1. Therefore, surely it represents a straight line. And since there are three components, it is a straight line in 3 space. Passing through the point 1, 0, 0. How we are getting this triplet 1, 0, 0? I told you, you collect the constants in each equation. The first equation x is equal to 1 minus t. Therefore, the constant is 1. The second equation is y is equal to 3t, doesn't contain any constant. Therefore, constant can be taken as 0. And in the third equation, z is equal to 2t, the constant is absent. But you can write 0 plus 2t, therefore the constant is 0. Hence, the given straight line in 3 space passing through the point, the triplet 1, 0, 0. And it is parallel to the vector minus 1, 3, 2. Minus 1, 3, 2. How we are getting that triplet? You consider the coefficient of t from each equation. From the first equation, coefficient of t will be minus 1. From the second equation, coefficient of t will be 3. So, second coordinate is 3. And from third equation, coefficient of t is 2. Therefore, the third component is 2. Hence, this straight line parallel to the vector minus 1 plus 3 plus, minus 1, 3, 2, or you can write this as minus I in terms of the vectors, minus I plus 3j plus 2k. So this is a vector which is parallel to the given straight line. Okay. Now look at the third example. It is very important. Describe the parametric curve represented by the equation x is equal to a cos t, y is equal to a sin t, z is equal to ct, where a and c are positive constants. So here you are given a parametric equation in 3 space. That is x is equal to a cos t, y is equal to a sin t, z is equal to ct. Let us check the graph of this. Now look at the third equation, z is equal to ct. As t increases, what about z? Since c is positive constant and z is equal to ct, z is also increases. So as t increases, z is also increases. Thus, the point xyz moves upward. Also, as t increases, the triplet, the point xyz moves in a path directly over the circle. X is equal to a cos t, y is equal to a sin t in xy plane. We know x is equal to a cos t, y is equal to a sin t, which represents a circle in the xy plane. Okay. Now the combination of upward and circular motion produces a clock screw shaped curve that wraps around a right circular cylinder of radius A centered on Z axis. So we have a circle and the curve is moving upward. Okay. So what we'll get? We'll get a picture like this. See, this is moving upward, Z component moving upward, and the base is in the form of a circle. And this is a very important, a beautiful curve which is called the circular helix. You can see the picture of circular helix here. Okay, circular helix, and see the base picture is a circle. Okay, and it is moving upward in upward direction. It is moving in upward direction, and this is the circular helix. Now we are moving on to vector valued functions. I hope already you have learned vectors in +1 or +2, but this is not vector, it is vector functions. For any parameter t greater than 0, if there exists a vector is denoted by r. You can see a bar symbol, okay, it denotes, it represents a vector. Then r is said to be a vector valued function of t. So if you are considering a parameter t, okay, if you are inputting a t, we will get the output as a vector r. If you are inputting a value 1, you will get a vector r1. If you are inputting 2, you will get another vector r2. So like that, for any t greater than 0, there exists a vector r. We usually denote vector valued function as r of t. And already we know in the case of real calculus, we are denoting real valued functions by y is equal to f of x. So for any x, if you are considering, you will get the corresponding y value. So x is the input, the corresponding y is the output. In vector calculus, we are inputting a scalar t and we will get the corresponding output as a vector r. Okay, so we can represent r as a function of t. In this case, we are representing y as a function of x, right? Hence, here we can denote r is equal to r of t, r as a function of t. Now, if r of t is equal to xti plus ytj plus ztk, then xt, yt, zt are called the components of R. This is in 3 space. So you can take the position vector RT as, in terms of its components, xti plus ytj plus ztk. So always remember, the vector valued functions are denoted by the symbol R is equal to R of t. Now let us take the first example. The parametric equation of twisted cube is x is equal to t, y is equal to t square, z is equal to t cube. What is the vector equation? See, we can represent an equation either in parametric form or in vector form. So here you are given in a split up form. X is equal to t, y is equal to t square, z is equal to t cube in a split up form. This is actually the parametric form. What you are asked to find? You are asked to find the vector equation. So vector equation means you want to combine these components. So what is the corresponding vector equation? We know vector equation is r is equal to, or you can write r is equal to r of t, that is equal to xti plus y of tj plus z of tk. Now you combine these components, so we'll get the vector equation of the given parametric equation, the twisted cube is r is equal to ti plus t square j plus t cube k. So whenever you are given a parametric form, we know how to write the corresponding vector form. Now I'll give you a few questions. Express the following as a single vector equation. X is equal to t plus 2t sine t, y is equal to t square minus cos t. You can see that this is split up form, right? That means the parametric form. Then what will be the corresponding vector form? R. You can write R as how? It's very simple, isn't it? T plus 2t sine t I, you put a bracket, plus t square minus cos t j. That is the corresponding vector equation. And similarly, you can try question number 2 and question number 3. You write the corresponding for each of these questions. Write the corresponding vector equation. Okay, combined form. Now, we are doing the reverse. Find the parametric equation of the following curves. You are given the vector equation r is equal to 3t square I minus 2j. What you are asked to find? You are asked to find the parametric form, parametric equation. That means the split up form. How can we write the split up form? You collect the corresponding coefficients of I and j in this case. So x is equal to 3t square, y is equal to minus 2. Okay, different equations. This collectively called, together called the parametric equation of the given curve. And in the second example, again you are given the vector form, the vector equation. R is equal to sine square ti plus 1 minus cos 2tj. This is the vector equation. What you are asked to find? You are asked to find the parametric equation. Therefore, by collecting coefficients of I and j, we will get x is equal to sine square t, y is equal to 1 minus cos 2t. This represents the corresponding parametric equation. And similarly, you can try question number 3. It is r is equal to 2t minus 1i plus 3 square root t j plus sine 3t k. Okay, so try to write the corresponding vector equation of the given curve. Okay, so I hope you all understood what I discussed today. I started with the vector functions, the graph of vector function and representation of vector functions in two different forms. One is the parametric form and the other is the vector form. Thank you very much.